I wanted to talk a bit about COPA, because that's something that I'm particularly passionate about, just as I am with CODESYS. I think CODESYS is an awesome product, and I'm a big proponent of it. CODESYS is a key part of the COPA, making COPA a reality, the open process automation, making open process automation a reality. So some of you may be familiar with it already. Forgive me if you are, because I'm going to go through this, just a quick thing of what COPA is, and then a current state of where COPA has evolved to today. But OPA, Open Process Automation, is an approach that was indirectly created by the large DCS companies. It really wasn't really their fault, but because of the approach that was taken with a tightly coupled system that like of the large DCSs that were applied to refining and petrochemical, they became very, very difficult to move from them or to evolve piecewise. To make a change was a horrendous amount of effort. And so, in effect, the end users wound up being held hostage by proprietary vendors and manufacturers. Not no evil intents of anybody, but it just they really were. They were stuck with whoever they had put in, and they began creating a standard for open process control systems to free themselves and the industry from that rigid relationship. To do that, they created, they had to be open standards that really were open standards. They weren't owned by any company. They weren't owned by end users. They weren't owned by manufacturers. They were truly open standards. And there is a company or an organization called the Open Group that specializes in this, in helping this become a reality. It's easy to talk about it and say, oh, we're all going to be open, but to really make it work for a community, it takes quite a bit of effort. So the Open Group that's what they do. And then within that, there is an Open Process Automation Forum, OPAF. That forum within the Open Group was established to develop these standards, be a standards-based, open, secure, interoperable process control architecture. And it really is a consensus group. And it's, as a standard organization, they can't, their charter does not allow them to promote any specific technical implementation of a standard. They just manage the standard itself. So the industry responded, though. The industry could see, yes, this was something whose time has come, and there is a real need for this. And I personally was part of this response. When this was first introduced by ExxonMobil many years ago, they put out a industry-wide invitation for people to show up to their inaugural meeting. And it turned out to be in Bethesda, Maryland, but I was determined to be there. Bethesda, Maryland, and it was in the middle of a blizzard. And we only had 1 week notice that when the meeting was going to happen. So I remember flying into Virginia, getting on the subway train that then eventually came out over, above ground, but there was so much snow that it couldn't run, and so they just dumped us off at a station there. The taxis and buses were not running, but entrepreneurship succeeded. It was an Uber. And I downloaded the Uber app because I had no need for it before, but I downloaded the Uber app, signed in, called an Uber, and the Uber drivers, they were out there earning money during the blizzard, and they got me to my hotel, and I was there at the meeting, and it was quite a good meeting. But I realized I stuck out like a sore thumb because I was this one small systems integrator amongst all these major companies, but I was determined to be there because I saw such a need for this in the industry. And so in general, the industry responded. And part of that response was the creation of a coalition for open process automation. And this was to create specific systems that complied fully with the standard and met the vision, the initial vision of open process automation. And this little image on this screen shows one of the demonstration systems that are put together, and you can see the if you can see the details, there's a lot of scratches and all on that keyboard because it was well used. A lot of people have seen this now. And this is open process automation architecture, and compared to the DCS architecture at the time this slide was produced. If you're familiar with the Purdue level 1, 2, 3, 4, that's on the left here, showing a very tightly coupled system, very rigid, from a typical DCS supplier. They took care of everything, but in order to make it all work, they had to be proprietary and very closed system. The right side of this slide, with the OPA reference architecture, it has this slide tried to put one of everything that could be. Not all of these things make a lot of sense. This was an early slide showing all the parts, but there's a more practical approach is this one here, where the distributed control nodes, which are where the logic is being solved, they're the logic solvers, are just compute devices. So those can be ruggedized PCs that have terrific capabilities, very high reliability and ruggedness, and are off-the-shelf devices. The Open Field Pass Connectivity Framework, OCF, was constructed using OPC UA as the base, but then with additional framework and definition on top of that to help with the communication between all of these different devices. Essentially, OPCUA, it could be a language, but it could be one device could be speaking English and another device speaking French. That OCF defined the language a bit better. Added additional extensions to the OPCUA to define how they're going to talk, and so each device can understand each of the others. You have one DCN, maybe it's a gateway talking to a legacy DCS or PLC. Other DCNs are just handling the I/O, and that's all they do is they just talk to the I/O, and then the DCNs that are running the applications communicate with them. Redundancy becomes as simple as just adding another DCN, which, let's say, a $2,000 piece of hardware, and now you have redundancy. So the benefit is, you can sort of read down the right side, is economic, total cost of ownership. It also is technical, and it advanced applications, predictive control and AI now can be added quite simply by putting them on a platform that will talk the OCF connectivity framework, so they can talk to each other. Since it is an OPCUA is the base for the communication, it has a built-in cybersecurity, the ability to handle that, but additional, cybersecurity is a continuously evolving situation. So as new approaches to cybersecurity become available, this can easily be added to this system. Security patching can be done without downtime. They're both technical and commercial benefits to open process automation. So this winds up with a control platform that, from the end user's perspective, is not locked into any particular piece of hardware or software. He's got significant cost advantages. Literally, a recent project we just evaluated, taking the COPA approach, was literally half price with the standard offering. And this was not comparing it against a large DCS, but this was comparing it against traditional PLC, mainline PLC approach. You can get market-leading control through CODESYS and all of its ecosystem. You have sophisticated cybersecurity inherent within the architecture, and the management of the system, which we really won't go into much, but it allows for management of the whole network, and such. There are resources available that will allow you to stay on top of the system, its system health, and rolling out security patches and such. All can be very much automated, reducing the requirements, the labor requirements, the personnel requirements, to make the system functional and keep it functional. We did not do this study, but this was one that was we were given the ability to see, and it was done by someone else though. But they were looking at a large plant in the UK, and one of the things that's really impressed me was this 50 to 70% less expensive. If you were to say it was 50 to 70% the cost, that's impressive. But if you say 50 to 70% less expensive, that means it was only 30% as expensive over its lifetime, potentially. And even in the worst case, it was going to be half the cost for and the time horizon they used for this, because it was a large plant that expected the system to be in place for quite a while, was 25 years, which really is not that long. 25 years goes by faster than we would think. And the ability to evolve during that 25 years by having a flexible system with components such as CODESYS, you can replace hardware, you can replace, you can add on different compute devices. There's just so much that is going to happen, we all know is going to happen in that 25 years. And so they had done this study for a 15,000 IO plant. We did ours recently for a 200 IO plant. And in both cases, the savings were comparable. Okay. So this is COPA. It was a number of major suppliers, including Phoenix Contact, CODESYS, Wood Group, Seaplane, Inductive Automation, ASRock. I'm sure there's many names that you recognize. Are the ones that put COPA together are COPA, which is realize the vision that the end users had when they first threw this challenge out to the industry.